All right, so we're going to be looking at this question here. The question reads, consider two sets, set A, a set representing consumers who prefer product X, and B, a set representing consumers who prefer product Y. So they're telling us define and interpret the following in the context of market segmentation. So for us to define it in terms of market segmentation, we must understand first of all what market segmentation is. So here is a definition on the screen of what market segmentation is. So market segmentation is the strategic practice of dividing a broad target market into smaller, more manageable groups of consumers who share similar characteristics, needs, or behaviors. So in short, market segmentation is just getting the broader picture or the broader target market and dividing it into smaller groups that we can easily manage or we can easily make studies of based on their behavior and their needs in those small groups. Okay, so that's what market segmentation is. Now they're telling us that we must interpret what these here are based on what? On the market segmentation. So the first one that we have on the list here is A union B. So you see here, that is A union B. So what is this going to mean? So first of all, we must understand or we must take note that we've said that A is equal to what? Consumers. So these are consumers who prefer product X. And then we have B, which is equal to consumers who prefer product Y. So these are the two verses that we have. So we have A, consumers who prefer product X, and B, consumers who prefer product Y. So now they want us to define first of all and interpret the following in the context of market segmentation. So now in the context of market segmentation, what is this A union B going to be? In short, they want us to define what is the union, what will the union mean? So this here will just mean these will be the consumers. These are consumers who prefer product product X. So consumers who prefer product X or product Y. So by the definition of the union, it's either it's in one set or the other, or in or in both. So we're saying they'll prefer product X or product Y, or they'll prefer they'll prefer both. So this is how we are defining A union B. Now they're telling us also to make an interpretation of this. So I'll write it here. So what do we make of this statement? So this statement just helps us to identify so that A union B is just going to be the total potential market for either product X or Y. The total potential market for product X or Y. So I'll just say total potential market for products of which we know it's X or Y. So that is the interpretation, the total potential market for product X or Y. So in short, this is looking at what our target audience are, people who are going to buy this product X or Y. So it's giving us that total there. Okay, so this is the interpretation of that one. Let's move on to the next one. The next one is A intersect B. So we have A intersect B. So which is just the intersection here. So the intersection of A and B. So what do we make of this intersection? So for the intersection, we're just saying this here is going to show us consumers. So this here is going to show us consumers who prefer both product X and Y. So consumers who prefer both product X and Y. So these, they want what? They want both the products. They want both the products. So what's our interpretation now of this? The interpretation of this statement, say consumers who prefer both product X and Y. So the interpretation is going to be, this is just showing us what consumers who are overlapping in terms of what preferences. So it shows us the potential of what for banding or cross promotions. In short, as we said, overlapping what preferences. So it shows us those that really are going to prefer both the products. So I just say overlapping preferences. Okay, so this is the interpretation of A intersect B. Okay, so let's move on to the next part now. So the next part is here, and that is the set difference of A and B. So set difference of A and B. So remember, the set difference of A and B can also be written as A intersect B complement. And by definition, what this means is, so if I write it in set beta notation, this is going to be the set of OX such that X is a member of A and X is not a member of what? A member of B. So this is how we define the set difference. That the element is in A, but the element is not in what? Is not in B. So what is this going to mean for us now? So this here shows us consumers who prefer product what? So in our case, they prefer what? Product, the product X, but they do not what? They do not prefer product Y. So this here is for consumers who prefer product X only and not what? And not product Y. So this is what the set difference is telling us. Products, consumers who prefer product what? Product X only and not what? And not product Y. Okay, now what is the interpretation of this here? So the interpretation of this is, it shows us a niche, or it shows us a group of what? A group of people or consumers who are loyal to what? To only one product, or who are loyal to only one product. In this case, which is what? Which is X. So it shows us a niche or a segment of consumers who are loyal to product what? Product X in this case. So it means that they don't want anything to do with what? With product Y. With them, it's always going to be what? To be product X. This is what this is showing us. Now, when you look at this A intersect B complement that follows, it's just the same what? The same interpretation. Consumers who prefer product X and do not prefer what? Product Y. And of course, the interpretation is just the same as we have made here. Okay, so this is how you would answer this question here. Right. So let's move on to the next part. So the next part is telling us enumerate all the what? All the subsets of the set there. So that set contains the number 5, 6, and 7. So they want us to enumerate all the what? All the subsets. So first of all, we can find the what? We can find the cardinality of what? Of the power set. So to enumerate all the subsets, in short, it's to find the power set. So suppose I say that this set here is just set A. So I say suppose A is equal to this set here, which is 5, 6, 7, like that. So what's the cardinality? The cardinality of a set is just how many elements are in that set. So the cardinality of A, denoted like this, is going to be just equal to what? To 3. Okay, and then when it comes to the power set, so the cardinality of the power set of A, like this here is equal to 2, and then the cardinality of what? The set A to the power of the cardinality of set A, which is going to be like that. So which shows us that we're going to have 8 subsets. So we're going to have 8 subsets. Now they want us to enumerate. It just means to list down those 8 subsets, and that's what we're going to do. So what's the first one? So always we know that by default that the empty set or the null set is going to be what? Is going to be is going to be a subset of what? Of every set. So it means that the empty set here is the first one that I list. So the empty set, and then what subset follows here. So the subset that follows is the set that is just containing what? The element 5. It's going to be a subset there. And then I go the one that contains the element 6. Then I go the one that contains the element what? 7. Okay, and from here I can go those that contain what? 2 elements, that is, that contains element 5 and what? And 6. And then I go the one that contains the element 5 and what? And 7. Then I go the one that contains the element that is 6 and what? And 7. Then we also know that every set is a subset of itself. So it means that the eighth subset is going to be 5, 6, what, 7. Okay, and this here lists down all the what? All the subsets of this set. Right. Let's move on to the next question. So the next question says, explain the difference between the null set or the new set and the what? And the empty set. So here the answer is, first of all, we need to know that there's no difference. There's no difference. So the null set and the empty set are both just what? Are both the same thing. So these are just all sets that are, they are both sets that are not containing any elements. So these sets do not contain what? Any elements. And of course, we do not them as like that for empty set or null set, or just a pair of what? Curly brackets with nothing inside, because it's empty. So there's no difference. It's just the wording that is used there that is different, where you have null and you have empty. Otherwise, they mean the same thing. All right, let's move on to this question. So the question says, a marketing survey of a company aimed to determine consumer preferences for 3 of its best selling products, A, B, and C. So they're saying that, let me read this again, a marketing survey of a company aimed to determine consumer preferences for 3 of its best selling products, that is A, B, and C. So that's what the marketing company aimed for. So the following results were what were obtained. So the results were the total number of consumers interviewed was there 14,520. Then of these, 8,150 consumers preferred product A. Then 5,540 consumers preferred product B. And then 4,010 consumers preferred product C. Then those that preferred both A and C were 3,150. Those that preferred product B and C were 1,820. And then those that preferred product A and C were 1,030. And then they're telling us that 2,520 consumers did not prefer any of the three what? Any of the 3 products. Then the task that they want us to find here is, first of all, find the number of consumers who liked all the 3 what? All the 3 products. That's the first question. Find the number of what? Consumers that liked all the 3 products. Then part B is the number of consumers who liked product A but not product what? B. Product A they liked but not product B. And then number C, that is the number of consumers who liked only product what? Product A. All right, so let us do this now. So let us do this. So first of all, we can involve what? A Venn diagram. So we can involve what? We can involve a Venn diagram in order to just get a visual representation of what is going on here. So I have my Venn diagram there. So we're dealing with what? 3 sets here, because there's product A and product B, and then you have product what? Product C. So I say A, B, and what? And C. But so the first question is telling us to say, find consumers who preferred what? Who preferred, who liked all the what? All the three products. Who liked all the three products. In short, the intersection of these sets. So in short, they want A intersect B intersect what? C. That's what they want us to find. But before we find that, first we need to find, they've told us that these 2,500 did not prefer any product. So I can write that here outside. So they didn't prefer any product. The 2,520, these here did not prefer any product. So now let me look at consumers who preferred at least one product. So out of the total, we have 14,520. These are the ones that took part in the interview. Then if I remove those that did not prefer any product, I subtract those, then I'm just going to have 12,000 remain. So the 12,000 is telling me these are consumers who preferred at least one product. So we know out of the three products, these 12,000 at least preferred one of the products. So now we're going to use the inconclusive exclusion formula to avoid what? To avoid double counting. So what is this formula? So I'm going to write it down here. So this formula, the inconclusion exclusion formula, which helps us avoid double counting, and I'll explain what that is. So we're going to say A union B. So I say A union B like this. I'm just getting the absolute value. Of course, we're saying, looking at people here, that's why we're saying that they have to be positive. And then the set what? Set A plus set B, like that, plus set C, and then minus A intersect what? Intersect B, like that, minus, and then minus A intersect C, and then minus, continue from here, that is B intersect C, and then lastly they are going to add plus A intersect B intersect C. Okay, so what is this? So definition of what the union is, you're looking at elements that are either in the set A. So in this case, because it's A union B union C, meaning they are in the set, either in the set A, in the set B, in the set C, or they're in all of the sets. If not all of the sets, then we're saying they're A or B, they're in the union of A or B, or they're in the union of in the intersection of B of A and C, and also in the intersection of B and C. Okay, so that's how it would be. So now look at here. We said A, so that's the whole set A, and then we said B, so that's the whole set B, and C, the whole set C. So then why are we removing this? It's because they are. So let me shade them in different colors so that you see. So if I shade this for A, and then I go here, I shade this for B, and then I go here, and then I shade, okay, let me use different color there. Then I shade this part here for what? For C. So you see that there are gonna be overlapping parts. So you have this part here when it comes to A and what? A and B, the intersection. So when we say the set A, meaning we meant the whole set A here, right? But then when we said B again, the whole set B includes this part here where they are overlapping, and then it means that I'm going to count that part twice, of which we don't want to count it twice. Hence, the saying that we're using the formula for inclusion, exclusion, what formula to help us do a double to avoid double counting. So you don't want to double count, because this part here you'd mean you'd count it twice. Same with the part here where the lines, the blue lines crisscross with the black lines. Same with the green with the black lines there. It would mean that you're gonna count that part twice. But then you see, then again, after removing all these intersections, it means you would have removed this part here, the middle part, which has all the three elements. You would mean that you would not have counted that. That means you have to add it back again. Hence, we're adding back the A intersect B intersect what intersect C there. That's the reason why we use this approach, or we use this formula. Okay, so let us now go back and then we compute. So a computation, going to use this top part here. We're going to have that our A union B union C, we found it to be 12. So those that chose at least a product, meaning that they'll be in the union. So that was the 12,000 which we had there. So that is our A union B union C. And then those that are in product A. So product A, we've been told that's 8,000. So we have 8,150 there. And then those that prefer product B, yeah, 5,540. And those that prefer product C, 4,010. And then what is A? The intersection. So we have there the 3,050, 150, and then minus B and C, you have 8,020, and then minus 1,030. So you have those there. Okay, and then next, your intersection has not been given in the question. So we're going to take that as X, because actually here they're saying the number of consumers who like those three products, which is what we're trying to find. So then when you do your math, you just have 12,000 there. When you add and subtract this side, you just get 11,000. So that's going to give us 11,700, like that, and then plus X. So which means that X is going to be equal to, so 12,000 minus the 11,700, which is just going to give us 300. So we get 300 there. So that means that those that liked all the three products were at 300. So meaning our 300 can come here like that. Okay, so that's where we bring our 300 to. And then next, it's very good to fill out your what? Fill up your Venn diagram. So to fill up this Venn diagram, then we're going to have that. What am I going to get? So here, I then move step by step. So I look at now those that liked, those that fall in the intersection of liking both A and B. They're telling me that they are a total of 3,150. So 3,150. So it means that to get those that do not like product C, but just like A and B, I have to subtract. So I subtract the 3,000. So 3,150, I subtract the 300 from there. Because in the 300, some of them like product C, but I only want those that like A and what? A and B. So I get 3,150, then minus 300, which just gives me, this gives me 2,850. Okay, then I go and say, okay, I want, this is product, those that prefer product B and C. But then, so B is here, B and C, you have B there, you have C there. So these here, you would have people that prefer both product B and C. But I want those that prefer B and C only. So to get the B and C only, I'm just going to say 1,820. Then I subtract 300 there. So 1,820 minus 300. And that's going to give me 1,520. So I get that there. And then I go to do the same for A and C. So A and C are those that like, so I want to get those that like the product A and C only. So it means I subtract that 1,300 minus the 300. So 1,030. So 1,030 minus 300 is going to give me 720. So I get 720 there. All right. So now after filling this up, then I want to look at now how many like product A only. So how many like product A only? They don't like any other product. They only like product A. So to do that, I'm going to add this value, that value, and that value. Okay, so I'm going to add 2,850 plus the 300 and then plus the 720. So after I add this here, I'm going to get, I get a value of, so let me erase this here. So I just get a value of 3,880. So this is the value I get. Then, but I know that those that like product A are at 8,150. So when I subtract, this gives me those that only like product A and not any other product. So I say 8,150 minus the 3,880. This is going to give me 4,270. So this is just like product A only. And then I go those that like product B only. So I'm going to add again so I add the 2,850 plus 300 plus this time around I add the 1,520 plus 1,520, and this here is going to give me, so this gives me 4,670. Those that like product B are there. So I'm going to say that is 5,540 minus the 4,670. So 5,540 minus the 4,670, which gives me 870. So that's 870 like product what? Product B only. I do the same for C. So C I add the 730 plus 300 plus 1,020. So that gives me 2,550. And then those that like product C are there. That is 4. That is just 4010. So I subtract 4010 minus the 2550, which just gives me 1460, like that. So this is just like product what? Product C only. Okay, so we have gotten now those that like what? Product C only. All right, so let's make space here. All right, so first of all, here we found our answer to be what? 300, as you had seen in the calculation. And then now the next one is telling us the number of people who liked product A but not product what? B. So in short, they're telling us A intersect B what? Complement, which is just equal to the set difference of A and B. So those that like product A but they don't like product B. And what does that mean? So it means B, we have a complement where B is, meaning we're not touching that part. So it means what we want, those that like product A but not C, are in sitting there, and they're not in anywhere in what? I mean, those that like product A and not B will sit in that set there, like that. So this is what you're gonna get. So you just add the values that are there in the green part, which is going to be 4,070 plus the 730. So I add 4,270 plus the 730, which is just going to give me 5,000. So 5,000 are the ones that like product what? Product A and not B. So there we got 5,000. Okay, and then what's the next one? So the next one is telling us the number of consumers who liked product what? Who only like product what? Product A. Number of consumers who only like what? Product A. So those consumers, what are they going to be? So let me just get to this part here, and then here we had found, so okay, I can erase and then write the number again. So here we had found 4,000 and 4,270. So here we found these, and as we were even discussing, we say that these are the ones that like product what A only. So we already found that, and that is just 4,720 other ones that liked product A only. Okay, so this is how you would do this part of the question. Now let's look at one more question for this video, and this is the question that is at hand. So the question says, how can the concept of sets be applied to analyze a possible combination of goods in a consumer's choice set? And then they're telling us, illustrate with an example involving two goods and give a graphical representation of this. So they're telling us, how can we use it to analyze what possible combinations of a consumer? So first of all, we take the example because they say to use an example. So example, let's say we have two goods. We have two goods, and we have goods that is X and Y. Just call them X and Y. Then what will this then mean? So let our choice set, let the choice set be, so I just say S be equal to X and what and Y, like that. So in our choice set, you can choose product dot, we can choose goods A or what or Y. So now what does this mean for us? So this brings us to the possible subsets or possible choices that we're going to what? That we're going to have. So our possible choices which are just what? Subsets of the set S. So this here is going to be, of course, number one, the empty set. So now what does this then mean? So this means that consumers choose neither the products. So, or we say neither of the products are what are consumed. So consumers choose what? Choose neither good A nor what? Nor B. So neither good X nor what? Nor Y. I mean not A or B, but X nor what? Nor Y. And then we have what? Where we have the set containing what? Containing X. So meaning that only what? Only the good X is what? Is chosen in this case. And then you have the one containing Y. So only what? The good Y is what? Is chosen or is preferred. And then you have X and Y, like that. So this here is going to give us the choice where we choose what? We choose both goods. That is X and what? And Y. So this is what then that would mean. So now, of course, they've told us to get this, try to draw a graphical representation of this. So me raise here. So what is this going to look like? So just have a Venn diagram like that, and then I'm going to draw, say, 1 and what? And 2. Yeah. So in this part here, where I say, okay, let me say this is good X this side, and that is good good what? Good Y. Okay, so and then what does this mean? So here we would have consumers for what? For X only, and there of course you have consumers for what? For Y only, and there you have consumers for what? For both X and Y. So this is how it would look for both X and Y. And then the same way that we have explained to say that where there's consumer X only, this means those that will just buy the product. What? The product X but will not buy the product what? Not buy the product Y. And while it's consumer, Y only those that will buy the product what? The product Y, but will not buy the product X. And there in between, of course, you have what? You have an overlap, which means that those that are going to buy both of your what? Both of your products. And this is how you would represent that and illustrate the question. Well, if you're new, remember to hit the subscribe button and then like, share, and write in the comment section if you want to see more of these videos. If you want to see us making more of such content. To access more, you can actually visit our website. So at Discrete Learning, Discrete Learning. So you just go into your browser there, and then okay, so into your browser, you just search Discrete Learning. So if you do not have an account, you can make an account, register up for an account here, and then after registering for an account, you then have access to different courses. You can enroll in any one of the courses here, and then after enrolling in any of the courses, you see here that we have down here statistics and probability for economics, but here we have mathematics for economics, which is what we are doing. So when you go here, you have access to whatever you will want, like past papers, quizzes, test exam papers. You find them here, tutorial sheets and assignments, and you have topic lessons. You're gonna find them in here, and then just like that, you have good learning experience. Well, this has been Tutor Marius, and I'll see you in the next one.